All right. So this is not a lecture video, but instead I'm going to pose a problem, right? And it's a very interesting problem, and it basically has to do with, of course, linear algebra, and also in particular we'll deal with a little bit of orthogonality in this problem. And it is the following. So suppose that you are given, say, a big sheet of paper, and you have an object over here, right? So this is my object, the black object, and suppose I shine light from some particular direction on this particular object, then there's a shadow which is formed on this sheet of paper, right? And the shadow is represented over here in black. Okay, so the problem over here is that suppose I give you the description of the sheet of paper. So the sheet of paper is basically a plane in R3. So if I describe the basis vectors corresponding to this plane, and suppose that I give you a direction for the light. So the direction is some vector d, right? So suppose that it is a unit, I give you a unit vector d, which is the direction along which I shine the light. Then given any object, any 3D object, how do you compute the shadow? So basically, suppose I describe this object, let's call it O. So O is described by some set of vectors, right? So it's going to be a continuous set, but at least since we want to somehow simulate it on a computer, let us assume that this can be discretized into some set of points x1, x2 up to xn, right? So this is a discretized version of a three-dimensional object. So O is basically a set of vectors in R3. So this is the object which is given to you. You're also given a direction d along which you shine light, and you're given basis vectors, the orthonormal basis vectors v1, sorry, let's not call it v1, let's say u1 and u2, which define this plane, an infinite sheet of paper, and your goal is to compute the points which correspond to this shadow. So given an arbitrary direction d and arbitrary vectors u1 and u2 which determine the plane, how do you compute the points of this shadow? That is the problem. And just to give you a quick idea of how it should be done, I will share parts of this code with you. Basically, how do you generate the three-dimensional object? Okay, so this is basically the code that I have written, and so let's take, for example, a cube, right? Okay, so I'll take a cube of which is of side 1, and basically I want to project it along on, say, the xy plane. Okay, so the xy plane, so the two vectors, the two basis vectors u1 and u2 are the xy plane. I go back here, so this is u1 and u2 which are described over here. So this is u1 and this is u2, and this is the object. I can select different objects. I have a hemisphere, a cube, and a sphere. So right now I'm choosing a cube. It's a discretized version, of course. And the direction of the light is, let's assume that since it's the XY plane, let's assume that the direction is along the Z axis. Okay, assume that it's along, say, the negative Z axis. Okay, and my goal is to plot the shadow, right? Get a picture of the shadow. So if I run this code, then I basically get a square, right? And that is essentially what one would expect. So if you take a cube, right? So suppose I have the XY plane. I take a cube and I shine light along this direction, then basically what I would see would be a square. So now what would happen if I shone the light in a slightly different direction, maybe something like this, right? So if I change, so if I maybe I put a component of D along the Y axis, let's say 0, 1, minus 1, 0, minus 1, minus 1. Now if I try to plot the shadow, well, essentially what I would expect a rectangle, and that is basically what I get. And as I increase or decrease the component along the y-axis, the length of this rectangle would increase or decrease. So if I make this point, say 2, then the component would increase, so it would be a longer rectangle. And if it's smaller, then I would get a smaller rectangle. All of this is fine. So if I shine it in a slightly different direction, if I also say, so this is from one side. So this is what happens if I shine the light from one side. If I make an oblique angle, so basically if I have, say, minus 0.2, shine it along this, then basically I would get something like this, right? So this would be what the shadow would look like, right? And the same thing would happen even if I change the cube to, say, a sphere. Basically I would get something like an ellipse, and depending on how big or small I make the component, this will become a longer ellipse, and the major and minor axis would be bigger or smaller. Okay, so your goal is to do the following. So given any such 3D objects, you have to plot the shadow, and you can do this purely using linear algebra. You should somehow come up with equations for in terms of u1, u2, and d, and basically They should be able to obtain the points on the shadow by solving some system of linear equations. And it's a little more, what is a little more special and something that you can try out in the beginning is to take the case where D is orthogonal to U1 and U2. So if I give you a set of two vectors U1 and U2 which describe this plane, and I give you an object, then assuming that the light is shown perpendicular to the plane, how do you find the shadow? And this has a very special structure, and it's something you've already seen in a previous challenge problem.